guys, we're starting this new chapter on trigonometry, and basically it is all about right triangles. Here's your cover page for your convenience, so we're going to ignore this for right now. Actually, this here is going to go where we need to. Okay, so let's keep going. So on this first section is just the Pythagorean Theorem. So you guys are very familiar with this. I've already warned you how important it is. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the lengths of the hypotenuse. And if you would Google that, you could actually see what that looks like. But the formula is a squared plus b squared equals c squared. Make sure this is always your hypotenuse. And your a and b are always your legs. Okay. So there are things that are called Pythagorean triples, and we've seen them. So it's a group of three whole numbers that satisfies that equation, where c is the greatest number. C is always the greatest number because it's the longest leg, and here they are. So basically what they're saying here, to be a triple, you've got almost kind of like, so if I go 3 squared plus 4 squared equals 5 squared, and that's true. Those are your triples. And you can see them with a variable. The converse of that is proving something is proving right triangle by using the Pythagorean theorem to see if true. To see if true. That's how you know it's a right triangle. So if you would do these, like 15 squared plus 36 squared is equal to 39 squared. So that's what we're talking about. Here is the inequality theorems. So we can determine if it is acute or obtuse or right. So if you know this is true, if this side is not equal to but greater than, then the triangle is acute. So the opposite of that, so a squared plus b squared is less than c squared, then you are obtuse. I think that's on the front page. That's what I was talking about. Where is that? Yeah, it's right there on that front. Okay. All right, so let's go here. Oh, it's right up here. Excuse me. There it is. So to find x, first of all, always identify your hypotenuse. In this case, it's always opposite of your right angle. So this is your hypotenuse, or my c, and these are my legs, or my a and b. So you're going to go 4 squared plus 7 squared equals c squared. So in my calculator, I just put mine somewhere and I don't know where it went. Oh, there it is. It's way over here. So 4 squared plus 7 squared equals 65. So 65 equals c squared, and then to get rid of the squared, you would take the square root of 65 equals c, and we are done. Let's try this one. This one is my a, b, c. Again, this is my hypotenuse. It's the longest. It's across from that 90-degree angle. You really have to know that. So I've got 8 squared plus b squared equals 12 squared. And I'm just going to do a little shortcut here. I'm just going to subtract that because I'm solving for b squared. So in my calculator, I'm going to say, what is 12 squared minus 8 squared, and that gives me 80. And then I'm going to take the square root of that. And what numbers, any perfect squares go into here? Yes. 4. Let's see, what are my perfect? We have 4. Does 9 go in? No. Does 16, 25? I'm thinking of my perfect squares. But 4 goes into 80. So b is equal to, how do I want to write this? Square root of 4 times 20. I mean, something else goes into it. It's 80. Take out that 4. So that's 2 times the square root of 20. 4 also goes into here. So did 16 go into 80? 80 divided by 16. It did. So I should have taken out 16. But I can still go because this is 4 times 5, square root of that. If I take out my 2, then b is equal to 4 times the square root of 5. I'm so sorry. I got there. And sometimes you will too, but you have to think in ALEKS, they're going to want you to simplify back to this. Okay, thinking of those perfect squares. So those perfect squares are in front of my classroom, but if you want to list them, because this reminder, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are the basics. Okay. So keep those in mind. I just wrote them at the top and you couldn't see. All right, so let's try this next one. Again, this is a leg. So we'll go A, B, C. Hopefully you can see this. I keep forgetting. So we have 24 squared plus b squared equals 26 squared. Subtract 24 squared. So b squared is equal to 100. Thank goodness this one's easy. B is equal to the square root of 100. So b equals 10. Is it b or x? Same thing. Here's one of those ladder things. So here's my right angle. So here's my hypotenuse. Here is an A. Here's a B. So you could go ahead and, well, I'll set it up correctly. So 16 squared plus b squared equals 20 squared. Subtract 16 squared. $144 square root of 144 is equal to 12 feet. Next, we need to determine if these are, what kind of triangle? Acute, right, or obtuse, or sometimes nothing. But let's go ahead and substitute it into. So we have 9 squared plus 12 squared equals 15 squared. Well, we don't know what this is going to be yet. So let's just solve this side. 9 squared plus 12 squared equals 225. So this side is 225. And then this side, 15 squared, is 225. So therefore, it's the right triangle. Let's try this next one. Remember, your longest length is always your hypotenuse. So 10 squared plus 11 squared and 13 squared. So 10 squared plus 11 squared equals 221. And what is 13 squared? 169. Since this is greater than, let's refer to that front page. Here's our front page. It is greater than, that it means it's acute. So that was pretty easy. All right, I'll stop there.